This is your ultimate guide to building multiplayer games in Unreal Engine, from core mechanics to pro tips and best practices. I've packed it all in one place just for you, so grab your dev hat and let's dive in. I remember when I started, lots of YouTube taught me how to make RPC calls. Although it works, when I created my game, no one told me about client prediction and server and client relationships, etc. This caused the game to act weird when I was the client and lag was introduced, causing animations and shooting out of sync, and so on. Well, today I will teach you how to make your life easier when it comes to multiplayer games. I hope this tutorial points you to the right direction. Well, I will tell you now, the tool that saved me from migraine is called Gas Companion. It's a tool to install Gas into your project with no C++ required. Stay tuned and I will show you how. First thing first, create a new project, click on Games, and let's begin with the third-person template and blueprints. Close all the dialogues. Note, Gas is free and can be installed to your project if you are a daredevil and know C++. I bought a third-party tool to install Gas fast without the extra headaches. Now remember, you do need to buy this tool in the UE market, which is $25 at the date of this video. A small price to pay if you do not want to deal with headaches nor C++. Once you bought this, on your new project, go to File, Plugins, and do a search for Gas Companion. Check mark it and hit the restart button to restart the editor. Don't ignore the warnings. Go to the right and click on the link to enable Gas. Now let's begin setting up. I usually start by Content folder. I right click and go to Blueprint class and click Game Mode Base. Then I will create a Gas Blueprint character. I hit Blueprint class and click on the All Classes drop down tab and search up for GSC character module. I will name mine BP_main character. Now let's open up BP_main character, then our BP third person character from the Content Blueprint. We will be using this to get the mesh model, animations, and blueprints and transfer them over to our new character blueprint. Let's click on the mesh and click the small magnify folder icon to take us to the mesh location. Now switch to our BP main character blueprint. Let's click on the mesh, then next to the magnifying tool, click on the left arrow to apply the selected mesh. You can always do this manually, but these are shortcuts that have helped me in the past. Now let's fix the mesh location by setting the C location to -88 and the rotation C value to -90 degrees. Let's go back to our third person character and copy the camera boom and the follow camera. Then we will go back to our character and paste it. It should be under the capsule. Now let's fix and adjust mouse rotation behavior. Click on the character movement and click the client rotation and enable it. Now on self, search up jaw and disable use control rotation jaw. Now it's time to copy all the blueprints from the third person character. Then we will paste that in our main character blueprint event graph. They definitely made this process easier in Unreal Engine 5. Before, we will have to copy variables over. Upon pasting, make sure you compile to check for errors. Now go to your content folder and let's open up the BP_game mode we created. From there, we will now change our controller to the Gas controller. And then we can now change the default pawn to the BP character we've been working on. Compile and save. Let's play the game. And it works, because I forgot to change the world settings to use our new game mode. On the right side, click the world settings tab and assign your new game mode. Hit the play button and as you can see, it is now using our new BP main character. And the reason why it's sliding without any animation is because we now have to assign our mesh with the proper animation blueprint. Let's go back to the BP_ third person character and click on its mesh. And hit the magnifying tool for the ABP Queen animation, and then we will go to our character blueprint and hit the arrow button in the anim class to assign it to the animation blueprint. Let's play, and there you have it, our character with our working blueprint animations. I can end it here, but let's give the character attributes such as HP, mana, and stamina. Click the ability system component. Here we have access to almost everything Gas provides, and it's all replicated, including the attributes. For starters, let's give the character some attributes by expanding abilities and granting attributes by hitting the plus sign in the granted abilities. Expand index 0 and look for GSC attribute set. Compile and play. It runs, but to see this in action, go to the console by hitting the tilde key and type show debug ability system. On the left side, you now see all the character attributes along with tags, active abilities, and so on. But that will probably be another video. By the way, if you have any questions or get stuck, feel free to comment below and I will try my best to help you. And don't forget to like and subscribe if you like more videos about Gas. I like the fact that you can see your character's location coordinates in real time. Now go to your content folder, right click and go to miscellaneous data table and click attribute metadata and hit OK. I named mine DT_player attributes. Now double click it and open it up. Here we will set our character attribute numbers such as HP, mana, and so on. Hit add, and in order for this to work properly, we must start with GSC attribute set period, followed by the attribute name like health, max stamina, mana, max mana. Copy and paste the first attribute for an easier process. Now we will click on each one and set the base value for each. I will make them different except the max value so we can see it in game. Go back to your BP_main character and let's assign the data with the one we created under initialization data. Hit play, and again in console type show debug ability system. But since we did it once, all I did was hit the up arrow key to get what I did previously and hit return. As you can see, the character value has the attribute values we inputted in the DT player attribute data tables. But let's do something cooler. Let's create a HUD with visuals. Go to your content folder and right click the empty area, and under all classes look for GSC modular player controller. Then hit the create button and name it BP_gas controller. In the BP_game mode, let's now change the player controller with the one we made. Now open up BP_gas controller and let's begin doing some blueprint coding. Get the node get player controller and cast it to BP_gas controller. Then create a widget. As you can see, Gas provides a few templates, but let's go for W_HUD for this tutorial. And lastly, let's add it to the player screen. Hit the play button and voila! You can see visually your player attributes. HP set in red to 80 HP, stamina set in green to 50, and mana in blue. Now the point of this video is to show you that these attributes also apply in multiplayer, which makes all the process easier. To test it out, next to the eject button, go to the net mode and select listen server and add 2 players. Now if we were to attack, each player will have their own HP, mana, and stamina. And there you have it, easy replication. Have you ever tried creating a multiplayer game where the server and the client see things differently and things were out of sync? Well, sit back and relax because today I will show you the correct way to replicate. Let's start off by creating a new Unreal Engine project. Click on Library and launch your preferred Unreal Engine version. In this example, I clicked on Games and then I chose the third-person template and I named the project Flag Rep. If you enjoy watching UE5 tutorial videos, don't forget to like and subscribe. First thing first, let's clear up this area by deleting the default meshes. Then we're going to start off by creating a new blueprint actor. I'm going to call mine Flag 1. I double click it to open it. And then we're going to add a cube for the pole. I should have chosen a cylinder for the pole, but for this example, I went with the cube. The main goal is to make it thin and long. You can change mode by hitting spacebar to change it from rotation to moving to resizing. And now we're going to add a cone to use it as a so-called flag. Then we're going to drag it up so it can be up on the pole. Then we're going to rotate it -90 degrees and push it outward for all to see. I wasn't happy with the height of the pole, so I made it taller. And then I dragged the flag all the way to the top. To showcase how to do replication right, I need some type of trigger, so I added a box collision. We are going to make it bigger and we're going to drag it in front of the pole so it could trigger as you walk to it. And voila, we are done with the first flag. Don't forget to compile to check for errors. Now we're going to drag our creation and drag it to our level. I then rotated it to 90 degrees so it could be in front of our spawn points for an easy trigger. I pushed the flag slightly forward and the spawn point slightly back to add room for the other flag. Now that we're done positioning the first flag, duplicate the flag blueprint and call it Flag 2. Since we created a copy, just drag it out and add it to your level. Adjust the height and rotate it 90 degrees so it can be facing the same way as the first flag. Make sure they're on the same grid so they can look asymmetrical. I separated them a bit so they can have a gap in between them. And then I hit play so I can test them out visually, and I was happy with the results. Now this is where we're going to start adding replication coding. For the first flag, I'm going to create the most common way people do replication. It is not wrong if you know what you're doing, but there is a better way. Click on the event graph and let's start adding blueprints. I've seen many YouTube examples showing this method. Like I said, it's not wrong for quick burst effects, but it is wrong when keeping things persistent, like if somebody joins mid-game. Now we're going to click on the box collision, and on the right side we're going to add on component end overlap. In the event graph, we're going to drag out the cone because we're going to make it change color when you step on the trigger. We're going to drag from the cone node and set a material. I went to the viewport to check on the material that the cone currently has. I clicked on the magnifying tool, and to my surprise there was a second material which we were going to use for this example. I selected the orange material, and then I went back to the set material and clicked on the arrow pointing left. That will take our selection to add to the node. So now every time we hit the overlap trigger box, the flag should turn orange. To finalize the flag, I made sure that the flag was replicated by check marking replicates and replicate movement if I do decide to add movement to this object. I then clicked on the cone object because this is what we're going to change colors, and I also replicated that object. I compiled and saved to check for errors. Then I clicked on the level to test. But then I decided to add a do once so it won't be triggered more than once. I compiled and I hit play, and everything worked as intended. When we overlap on the trigger box, the flag should now turn orange. Now we're going to test this with multiplayer. Make sure you change the number of players to 2, and then on net mode, change it to play as listen server. I then hit play and I adjust the screens so I can have a better view of both viewports. And like I said, this method does work. When I overlap with the trigger box, the flag now turns orange, and you can see it on the client side and on the server side. If you have any questions or are getting stuck, feel free to leave a comment below and I'll reply as soon as possible. Now we're going to close out and test the server. And again, everything works great. But what will happen if we reconnect or if we join mid-game? On console, I hit the tilde key and typed in reconnect. And here is the problem. As you can see, the flag turned blue and it's not persistent. The client sees the flag as blue and the server still sees the flag as orange. This is a big problem if you want things to be persistent, especially when people join mid-game or reconnect. So now it's time to do it the proper way. Let's go into our content folder and double click on the flag 2 blueprint. Go into the event graph, click on your box collision, and add on component begin overlap. Before I forget, we're going to replicate flag 2 by clicking on self and clicking on replicates checkmark along with replicate movement, and then we're going to click on cone and we're going to check mark components replicates. To do this properly, we're going to create a bool variable and call it flag change question mark. For best practice, I always like to add a question mark for the boolean. I then dragged out the flag change variable and clicked on set. I checkmarked the node and set it to true so that when this node is ran, it will be set to true. And this only happens when somebody overlaps with the box collision that is in front of the flag. Just like the other flag, I'm just gonna allow this to run it once by adding a do once node. I attached everything together, compiled, and double checked that everything was ready for a test. Before hitting play, I remembered that the boolean needed to be replicated, so I clicked on it and I set the replication to RepNotify. When you add RepNotify to a boolean, it will automatically create a function for you. Double click the function, and here we can add the function to perform, and it will be replicated. And guess what? It will be persistent. So now I'm going to demonstrate the right way by setting the material change in this function. I went to flag 1 blueprint and I copied set material node. Drag out the cone to set it to the set material target. And then we're going to connect everything together. Since I copied the set material from flag 1, I do not have to set the material. Now it's time to test. Let's hit play and it's time to test with the server. I ran to the trigger box on flag 2 and everything worked as expected. Now for the true test, let's reconnect as a client. On console, I typed in disconnect, which disconnected me from the server and connected me to my server, which should, in theory, make the flag blue. I then reconnected to the server session, and guess what? The flag is still orange. And guess what? Any new clients connecting to the server will see the object the same as everyone does. Just to double check, let's type in reconnect and see what happens. Instantly, you'll see the flag is still orange. If you still don't believe me, I'm gonna do it a second time. I went to the console and hit reconnect, and guess what? The correct flag to the right stayed orange and the incorrect flag to the left stayed blue. You now know the correct way to replicate. Don't forget to like and subscribe if this video was useful to you. It will really mean a lot to me. Now for more UE5 videos, click on the playlist to the right. Have you ever ran into the problem where you play as a client and your animation does not sync up with your input? This mainly happens when lag is introduced. I recently created a video on how to fix this problem using the GAS framework, but today I will show you how to do it without it. So sit back and relax, because today you will learn more about local prediction. As a recap, in this example, we're playing as the client, and every time we shoot, the animation does not sync with the actual input press. The yellow print string that says instant shot represents our button press, and the green represents when the shot is actually fired in the server. So in other words, every time you shoot as a client, the animation plays a few seconds later, which is very unresponsive and equals to a bad experience as a user or as a client. Okay, so first thing first, I'm gonna open up my previous character from my previous project. If you're interested to see part 1, feel free to click on the card on the upper right. But anyways, let's head to the event graph and let's recap what I did previously. As you can see, I created an input action that is connected to a print screen that says instant shot. And then it's hooked up to the server shot. The server shot ran on the server, which then is connected to a multi-shot event graph. That multi-shot event is Multicast, and then that Multicast is connected to the print that says I shot the gun, with the animation being played every time we click. As you saw previously, relying on RPC code to play the animation is bad practice. So what we simply need to do is grab the play montage and drag it all the way in front of the input action. I will increase the animation speed so you can see the reaction time better. And just so you can see what I did to emulate lag, I went to the advanced network settings, and then I enabled network emulation, and then I set the emulation target to everyone. And for the network emulation profile, I hit custom because I added more lag, about 100 more for the latency. Let's go ahead and hit play, and voila. Now as a client, every time I shoot, I can now see my animation instantly play. You might notice that the server does not see the animation being played. That is because the client is playing that animation locally. To alleviate the problem, I copied the play montage and put it in front of the input action shoot gun. But before it, I added a branch with the is locally controlled connected to it. If it's true, it will play the montage, but if it's false, it will go to the server RPC call. The server event will then call the multicast event, and in the multicast event, I added another branch with the is locally controlled attached to it as well, and if it's false, it will play the montage as well. And as you can see, the play rate is increased for a faster animation. I then hit play, and voila. You can now see that the server sees the client shoot, and vice versa. And now you know how to locally predict without using GAS. This is one solution out of the millions that are out there, but at least now you have one. And now you might be wondering, what will happen to the bullet? Does it also lag? Well, to answer that question is yes, it also lags, but it's on the server's time. If you're the client, your computer needs to communicate to the server, and then the server will shoot the bullet when it receives the message. There are a lot of smoke and mirrors encoding that you can do to alleviate this, and this is called client prediction. I won't talk about client prediction today because I can write a novel about it, but perhaps I'll talk about it in another video. You now know how to locally predict and make your multiplayer game feel more responsive. Have you ever noticed in multiplayer when you play as a client, sometimes things don't trigger? In this example, I created a custom HUD that should trigger every time the client connects to the server. The custom HUD says, "Hey player you," and as you can see, the message is not consistent. It does not trigger all the time. In today's tutorial, I will teach you how to fix this problem. So sit back and relax because today I will teach you how to make events reliable. Before I begin, make sure you hit that like and subscribe. First thing first, I started by creating a new project. Then I clicked on games and I chose the third-person template. It was hard to choose a name for this project, but I chose does not trigger because we're going to show you that things sometimes don't trigger all the time in multiplayer, especially when lag is introduced. What we're going to do first is making the project multiplayer by changing the number of players to 2, and on net mode we're going to click on play as listen server. I went ahead and I hit play just to see the windows visually. I then closed out and created a new actor blueprint. The deaf actor basically destroys the actor on overlap. But then I thought about something faster. So I went ahead and started creating a new HUD, and I simply called it HUD. I double clicked the HUD and then I searched up canvas. I drag canvas panel all the way to the bottom. Then to display the HUD, I'm just gonna add text in the middle. I changed the text to hello person you, and then I anchored it right in the middle. The second thing I did was increase the size to 50. I enlarged the green box just so it can be the same size as the text. I compiled and I was thinking where I was gonna display this HUD. And for a quick demonstration, I was gonna add the blueprints and the BP third-person character. I first created a widget and I attached it in the begin play area. I selected my newly created HUD blueprint, or widget, sorry, and then I added to the player screen. I compiled and I hit play, and everything worked as planned. If you get stuck or have any questions, don't be afraid to leave a comment below. I then created a custom event for the HUD so I can RPC to it later. Then I linked the event begin with the create HUD event. And here, this is where we're gonna actually test this. And this is where we're gonna create our problem. I went to the internet settings to add lag. I checked mark enable network emulation, and for emulation target I hit everyone, and for the network emulation profile I hit bad. For exaggeration I added more lag, and then I hit play. I hit play and everything still worked right, but the client did take a while to load in. I then added a delay node because I was gonna destroy the HUD after 5 seconds. I then added the remove from parent, and then I dragged the HUD to the remove from parent. After 5 seconds it will trigger. I hit play, and as you can see on the left side everything worked well for the server, and on the right side for the client everything worked the same way, much slower because we introduced lag. Now in a multiplayer scenario, this create HUD event will have to be RPC'd in. To bog down this event, I created a for loop that was going to spawn in an actor so I can intentionally slow down the client so that things won't trigger properly. When I compiled, I got an error because I was spawning in a target viewport. What I really needed to do was spawn an actor from class, but I did not see it because I forgot to checkmark context sensitive. Upon adding the node, I connected everything together. Make sure you add a spawn transform by dragging out and adding a transform. I did not care where the object will spawn at, so I didn't care about the location. My main goal was to spawn 10 to 30 objects so I can bog down the client. I then hit play to test out if things would trigger, and surprisingly everything worked as it should have. As I was playing with the third-person character, I was wondering why everything was working properly. I did several things to purposely bog down the client and have things not trigger, but I was not able to accomplish this. Everything was working properly. After several minutes of debugging to intentionally break the game, I then had an aha moment. I then remembered that this tutorial was for a multiplayer example. And in a multiplayer example, the create HUD is to be called via RPC. So I made sure I created 2 events, one for the server and one to be multicasted. I connected everything together and I made sure I was about to spawn 50 objects just to be on the safe side, just to make sure things do break, and when I hit play, the client no longer saw the HUD. And the reason why the client did not see the HUD was either by lag or by a packet loss, which caused the event not to trigger. This was a giant issue for me in multiplayer. For example, every time I died in my game, I was not able to reselect my character because the HUD would not show up, causing a big bug in my game, Bloodbound. This led to players to restart the game or disconnect from the server and reconnect. This was a major bug in my game, and in a minute you're gonna find out how to fix this. Back to the tutorial example, I lowered the spawning of the third-person character, and then I hit play to test it out again, and to my surprise, the event still did not trigger. I played it a third time just to make sure, and it still did not trigger. This is exactly what I wanted to demonstrate what happens when lag is introduced and when clients are bogged down by several nodes. For one more test, I bypassed the for loop to see if we can get that event triggered. I hit play, and yes, the event did trigger, and the reason why is because we are not bogged down by the for loop. So how do we forcefully trigger this event on a client that is lagging? Well, we don't want any events to misfire, so in order to alleviate this, all we gotta do is click on the server event and make it reliable. And same thing with the multicast event, we checkmark reliable. Yes, it was that simple. I could have showed you this from the very beginning, but my job here today was to show you what the reliable option was good for. As you can see, no matter how laggy the client is, this event will always trigger. Be careful checkmarking reliable though, because it is not best practice to checkmark this on every single event. It could eventually bog down your game and cause weird problems in multiplayer. Use it sparingly and wisely, and just add it to things that are very important, like adding player scores and so on. But try not using it on events that keep firing, like sound effects or particle effects. Today I'm going to share my top tips on becoming a better multiplayer developer in Unreal Engine. These are lessons I've learned while working on my multiplayer games, so I'm passing them on to you to help you avoid the hassles and headaches I had to deal with. Tip number 1, start using RepNotify. Now, RPC calls are great and they get the job done, but there are some cases where you need to use RepNotify. Let me explain why. RepNotify is key for anything stateful. Think about things like changing a character's color or when a door opens or closes. If you only rely on RPC calls, players who aren't in relevancy, like those who are too far away or who joined the game late, won't see those changes. But with RepNotify, they will, because it ensures the changes are replicated across clients, even for those who weren't there when the change happened. For things that don't matter for late joiners, like attack animations or visual effects, you can stick with multicast RPC calls. I actually have a full video on RepNotify. Check out the link in the top right. Tip number 2, always develop with optimization in mind. This goes for both CPU usage and the assets you're using in your game. If you're building for mobile or targeting lower end consoles, be mindful for things like polygon counts and unnecessary complexity in your scenes. Fortunately, with Unreal Engine's 599 system, handling high poly counts has become a lot easier. 99 is a real game changer for optimization. Always remember to check your performance stats as you go, especially when developing multiplayer games where network traffic can be heavy. This will help ensure smooth gameplay for everyone no matter their device. Tip number 3, organize your blueprints in code. I know. As a solo developer, we often think it's my code, I know where exactly everything is, right? But trust me, when your project starts to grow or when you need someone to help you out, poorly unorganized code is a nightmare. Comment your blueprints, color code sections, and make sure your code is structured logically, even for yourself. If you take a break from your project and come back later, it's easy to forget your own structure. Organizing your code now will save you a lot of time and frustration down the line. Tip number 4, start thinking about parent classes and child relationships early on. This is going to make your life so much easier when creating characters, game modes, or even weapons. For my game, I created 2 parent classes, one for vampires and one for vampire slayers. The vampires are focused on melee attacks, while the slayers are more ranged. From these 2 parent classes, I created child classes to make unique characters while keeping the core mechanics consistent. This way, I didn't have to reinvent the wheel every time I wanted to add a new character. Trust me, parent-child relationships in Unreal will speed up your workflow and help things keep organized. Finally, tip number 5. Step outside your bubble and start looking into frameworks. One that really changed my life as a developer is GAS, Gameplay Ability System. GAS is a framework that helps handle abilities and their replication across clients. It comes with tons of useful tools that make managing abilities a breeze and help prevent your blueprint from turning into spaghetti code. With GAS, you can handle complex multiplayer interaction in a clean, organized way. If you want to dive deeper into GAS, check out the description below or at the end of this video for more resources. Alright, here's a bonus tip for you. Organize your files into folders. Sounds simple, but let me tell you why it's important. When you keep your files organized, you're keeping a solid structure, making it easy to find what you need, even after a break from the project. It also helps a lot when working with others. If you're sharing parts of your project with a modeler or a programmer, for example, you'll want to give them access only to the specific folders they need. Like models or blueprints, organized folders make this easier, whether you're sharing through GitHub, a repository, or Unreal source control features. And there you have it. Those are my top 5 tips plus a bonus tip for becoming a better multiplayer developer in Unreal Engine. Hopefully these tips will save some headaches and help you avoid redoing your project multiple times. If tip number 5 has caught your attention, you'll definitely want to dive deeper. Click the video to the right to watch my full breakdown on the gameplay ability system and see exactly how to make managing multiplayer abilities a lot easier. Trust me, it's a game changer. Today we're tackling replication in Unreal Engine 5. I'll explain in a way that even if you're new, you'll get it. And if you're not, stick around because I'll share tips that could save you hours of frustration. Here's what we'll be covering today. Replication variables, replication functions, replicated characters, replicated objects, testing play modes, handling late joiners, and net update frequency, and last, net call distance square. Understanding these will help you avoid common multiplayer pitfalls. Ready? Let's dive in. First, let's answer the big question. What is replication and why do we care about it? Replication ensures that data and actions are synchronized between the server and all the clients in your multiplayer game. Without replication, your server might think one thing and the client might see something completely different. Not good. Let's make it visual. Imagine I'm a client and I shoot. Without replication, the server doesn't know about my shot. Hacker! And no one else in the game sees it. Now that's awkward. With replication, everyone sees it. The same bang. This is the heart of multiplayer development. If you're planning a multiplayer game, start by understanding replication. Don't do what I did and start a single player game only to try converting it later. Trust me, that's a pain. You don't want that. Let's talk about variables. Variables are the foundation of any game. Things like player health, ammo count, or scores. But here's the thing, you have to tell Unreal which variables should replicate. Here's how. Open your variable in Blueprint Editor, right-click the variable and select Replicated under the Replication dropdown. Save your blueprint. Now what does this do? It ensures that when the server updates this variable, all clients see the same value. For example, if players' health changes, all players will see the updated health. Common pitfall? Don't assume all variables need replication. Only replicate what's necessary, otherwise you'll bog down the network. Variables are just data. What about actions like firing a weapon or opening a door? That's where functions come in, and yes, they can be replicated too. There are 3 types of replicated functions. Server functions. These run on the server. Use these for actions like dealing damage or spawning objects. Client functions. These run on the client. Use them for client-specific effects like screen shake. Multicast functions. These run on both the server and the clients. Use these for global events like explosions. Imagine you're changing the color of an object in the level. To ensure everyone sees the color change, you'll use multicast functions. Create the function, mark it as multicast, and call it from the server. Don't forget about that. Good news, Unreal has built-in replication for character movement. Walking, running, and jumping work right out of the box. But if you want to add something fancy like sprinting or leaping, you'll need to get your hands dirty. Here's how. Use a server function to handle the logic on the server. Add client-side prediction so the action feels smooth even if there's lag. Test for edge cases like what happens if a player tries to leap while lagging. Unreal 5 is improving replication all the time, and there are plugins available to help with the advanced movement. Objects can also be replicated, but here's the catch. Physics objects like rolling balls or thrown items don't replicate well on their own. Why? Physics isn't deterministic, meaning it can behave differently on each client. To fix this, you can set up a custom replication framework, or you can use plugins like MoveSync, which you can get at the Fab Store. I heard great things about it. Without these fixes, one player might see a ball rolling left while the other sees it rolling right. Not a deal. When working with replication, always test in different play modes to catch potential issues early. Standalone runs a single player instance without networking. Play as a listen server, one player acts as both the client and the server. Dedicated server mode, best for testing how clients connect to central server. Multiple clients allows you to check interactions between multiple players. Testing with different play modes will help you debug synchronization issues before they become a problem. Now let's learn how to handle late joiners. What happens when a new player joins a game that's already in progress? If you don't handle replication properly, they'll miss important states like an open door or a destroyed crate. To fix this, use onRep functions to update new players on the current state of replicated objects. Initialize objects and begin play to ensure they're ready for late joiners. I actually made a full video on handling late joiners. You can check it out by clicking on the info box in the upper right hand corner, or I'll also link it at the end of this video. By the way, if you're enjoying this, hit the like button and subscribe so you don't miss any of my latest Unreal Engine tutorials. Now let's talk about net update frequency. Net update frequency controls how often an object states updates over the network. Here's how to think about it. High frequency for fast moving objects like vehicles. Now low frequency for static objects like props. Adjusting this can save bandwidth without sacrificing gameplay quality. Now let's talk about net call distance square. This determines the distance at which the server stops replicating an object to a client. An example will be like a battle royale game. You don't need to replicate a destroyed crate to players who are miles away. By setting a call distance, you optimize the game and save resources. So there we have it. We cover replicating variables, replicating functions, replicating characters, replicating objects, testing play modes, handling late joiners, and net update frequency, and last, net call distance square. Multiplayer can feel overwhelming, but trust me, once you get replication down, the rest starts to click. Why can't clients change variables in Unreal multiplayer? You probably heard don't trust the client 100 times, but today I'm going to show you exactly why that matters, how hackers actually abuse that, and what Unreal does to protect your game. We'll break it down with real-world cheat tools, show insecure versus secure blueprint setups, and how to lock your game down with server RPCs the right way. In Unreal Engine's multiplayer system, only the server has authority. Client can do stuff like move around, shoot, or interact, but they are not allowed to control the actual game state, like health, score, inventory, etc. When a client tries to change something like player health, they're only changing it locally. That change isn't real. It doesn't replicate, it doesn't matter. The server holds the real version of the variable, and that's what gets synced to everyone else. Let's say you did let the client handle something important, like subtracting damage when they get shot. They could just use Cheat Engine, a free memory editor, to change player health to, let's say, 9999, or freeze it so it never drops. They could also bypass your damage function entirely, or call it with fake values to avoid dying. If your server listens to the client blindly, you basically handed cheaters the key to your game. Here are some real tools people use to break games. Engines like Cheat Engine, which edits health, ammo, speed, and lock values in memory. They also use DLL injectors, which inject code to override logic like is dead equals false. They also use packet editors, which intercepts and modify network data on the fly. And another thing they could also be using is game trainers, custom hotkeys menus to trigger cheats with a click. All of these work by exploiting client-side logic. That's why you never want to put critical systems in the client hands. So how do you let players interact with the game securely? You use server RPCs, remote procedure calls. A server RPC is a function that clients call, but it runs on the server, which keeps everything in sync and secure. For example, if a client gets shot and calls server take damage function, the server receives it, verifies it, and it verifies the request and subtracts the damage. Then it replicates the updated health back to all clients. You can even add additional validation to prevent bad data from going through. Here's the insecure setup. In this version, the client takes damage and modifies their own player health. A cheater could overwrite this, ignore it, or even increase health instead. If you're replicating that value from the client to the server, it's game over. Here's the secure version. Player health is replicated from the server only. Take damage is a server RPC. Client sends a damage request. Server checks if it's valid. If yes, server subtracts health and replicates the change. In this setup, cheaters are locked out and the server controls the truth. Want to go even deeper? Don't even let the client tell you they took damage. Let the server handle the entire chain of logic. A bullet hits, server registers collision, server confirms it's a valid hit, server applies the damage directly. The only thing the client does is say, "I fired." The rest is handled where it can't be hacked. That is why Unreal doesn't let client change variables, and why you shouldn't either. Keep your logic server side, validate all inputs, and don't trust the client with anything critical. If this helped you level up, don't forget to like and subscribe for more game dev tutorials. Got a game you're working on? Drop its name and where to find it in the comments below. I might give you a shout out in the next video. For more dev videos, click on the video to the right. Thanks for watching.